Question 5. Ethanoic acid and ethane 1,2-diol react together to make a diester. That's a molecule with two ester links, two COO links in there. And an ester link forms when you have a carboxylic acid reacting with an OH group. So let's have a look what we've got. We've got two lots of COOH, we've got two ethanoic acid molecules, and I've drawn one and I've drawn another at this end. You'll see why in a minute. And I've got ethane 1,2-diol. It's got an OH at either end, one on carbon number 1 and one on carbon number 2. And what happens is when you get a carboxylic acid group and an alcohol group, an OH group, they can react together to make water. Especially if you've got something like concentrated sulfuric acid as a catalyst that's going to help remove the water. And that reaction is called a condensation reaction. You make an ester, a COO group, and it's called a condensation reaction, and you make a condensation polymer. Now at the other end I've got a COOH here and I've got an OH here. I'm just going to flip this around so we can see what's going on. So I've just flipped it around. Instead of being CH3COOH, it's now going CH3COH from the right. And now we can see that the OH of the COOH and the H of the alcohol can make water, and they can do it this side as well. The OH at this side and the H, so the OH of the carboxylic acid group and the H of the alcohol can make water on this side as well. And I'm going to remove those waters. So I've now removed the OH of the carboxylic acid group and the H off the alcohol on that end, and the OH of the carboxylic acid group here and the H from here, and now all I do is join them up, and then that gives me the structure of the diester. I could draw it a little bit better if I wanted to, something like this: CH3CO, CH3CO, that's a double bond O, and then I've got an OCH2, CH2O, OCH2, CH2O, and then I've got an OC or a CO, a carbon to oxygen double bond there, a CO, and a CH3 at the end. Let's have a look what's happening next. I've got at the start of a reaction I've got ethanoic acid and I've got ethane 1,2-diol. I've not got any of my products yet. I've got 0.470 moles of ethanoic acid and I've got 0.205 moles of my ethane diol. At equilibrium, so this is a process called dynamic equilibrium, where the rate of the forward reaction and the rate of the backward reaction are the same, and the concentrations of the reactants and products are no longer changing. At that point I've got 0.180 moles of my ethanoic acid left. So my first step is to work out how much has been used up. So if I take 0.470 and subtract 0.180, I can work out that 0.29 moles of ethanoic acid have been used up. Every time 2 moles of ethanoic acid are used up, it reacts with 1 mole of ethane diol, ethane 1,2-diol. So 2 moles of my ethanoic acid react with 1 mole of my ethane 1,2-diol. So if I've just used up 0.29 moles of this, I must have used up half of that amount of ethanoic acid. 0.145 moles of this must have been used up. Now I can work out how much I've got left. I started with 0.205, I've used up 0.145, so I must have 0.205 subtracted 0.145, 0.06 is left over. How much of this is made? Well, every time 1 mole of ethane 1,2-diol react, I make 1 mole of my ester. So how much of this has been reacted? 0.015 moles of this has been reacted, has been used up, so I must make 0.145 moles of this. Every time I make 1 mole of that, I make 2 moles of water, so if I double this, 0.145 multiplied by 2 gives me 0.29 moles of water.